welcome to my talk. This talk is called Printer Perfect, a case study in building a 3D printer UI with Nerves and Liveview. And so a little bit before we get started, we're going to talk about who I am. My name is John Palgut. I'm a software developer with about 10 years of professional experience. And luckily for me, my last 4 or so years, I've been able to work in Elixir. One thing, I'm always kind of tinkering with stuff. So I go home and I write software and I do these side projects and I build things with Raspberry Pis and just all sorts of tinkering and how does this work and can I take it apart? And so for me, like 3D printing is kind of a tinkerer's dream. 3D printers, there's open source hardware, there's open source firmware, there's open source control software. You can sort of print new pieces for your printer to kind of customize it in ways that other people haven't even thought of. It's just a super cool like tinkering hobby. And so one of the pieces of software I use with my 3D printer is called Octoprint. And Octoprint is a printer host, which means it's kind of responsible for talking to a printer and sending print jobs and keeping track of the status of those print jobs. And you can move the printer around or send commands or do various debugging things. And Octoprint's like super good. It's tons of features and an extensible plugin system, and it does way more than I'd ever needed to. But that little tinkerer part of the back of my brain kind of says, hey, could I write a 3D printer host with Elixir? And so I set out to do that for this talk. And before I got started, I sat down and I came up with some goals, things that I felt like a 3D printer host would need to have in order to me feel good about something that I'd written. And I've ordered these goals on this slide in kind of like the ones I consider most necessary to the ones that are sort of nice to have being at the bottom. And you may be saying, John, it looks like printing is like second to last. Like, shouldn't that one be up at the top? Like, printing is pretty important for a 3D printer. And so for me, I've kind of thought of some of these things as sort of, they're the core pieces, and it's like learning to walk before you crawl. I wasn't necessarily sure that I could accomplish, printing with a 3D printer, and I wanted to make sure I got the crawling steps done before I started stumbling around everywhere. So what tools did I choose? And when choosing my tools, I sort of took a look at how Octoprint did stuff, because Octoprint is open source and very popular. So Octoprint is written in Python, and I'm a little bit biased. But I think that anything Python can do, Elixir can probably do just as well, if not better. So we're covered there. The hardware, I wanted to run this on a Raspberry Pi, which is connected to my printer via a USB cable. And so luckily for me, Nerves is really great at getting your Elixir projects up and running on a Raspberry Pi. Similarly, Octoprint uses a library called PySerial. It turns out the S in USB actually stands for serial. And so this PySerial library allows Octoprint to talk to the 3D printer. And for us, there's a library called CircuitsUART, which is part of the Nerves family of libraries. And so we can use that to talk to the printer overseer. And then finally, Octoprint has kind of a real-time web UI built with Flask and some client-side JavaScript. And we can sort of throw out the JavaScript part and just rely on Phoenix and Liveview to get things done. So where did I start? If you've never written a Nerves application before, one of the things that they recommend you do is structuring your poncho in what they call, or project in what they call a poncho project. And so essentially a poncho project is a bunch of standalone Elixir applications in a single directory. And then there's a firmware application that is your Nerves application. And it pulls those other applications in as dependencies and it starts them up and it bootstraps the hardware and gets you going. And the way they kind of recommend that you do this is it allows you to develop and test these projects separately. So for example, I could develop and test and iterate on the UI all the way on my desktop. And then when it's time to put it on the printer, I don't really have to do anything because I've already tested it on my desktop. And so speaking a little bit more about the firmware application, this was the part of the application I touched the least. I basically ran, mixnerves.new. I told it a little bit about my Wi-Fi information. I told it how to pull in my other applications. And that was it. It just kind of worked. It was a lot more straightforward and really easy than I thought it would be. So that was pretty cool. And then the next application is the printer application. And this is just a normal Elixir application. I created it with the mixnew -- supervisor flag. And the way I like to think about this application is it's like a library for all things dealing with my 3D printer. If I want to move the extruder, there's an API call for that. If I want to heat it up, there's an API call for that. If I want to get what's the status of my printer, there's an API call for that. And so this one's much more complex, and most of the development actually went into this application. And so I went over a couple different possible application architectures, and the one I settled on is this. I've got a named singular gen server called the printer server. And the printer server is one responsible for sort of handling API requests. and keeping track of the state of the printer. And then it also spawns these connection servers, which are gen servers that manage a connection. And in this definition, a connection is the piece of code that's going to actually do the sending of commands to the printer over USB. And so one Nerves tip I've sort of come across as I've done Nerves project is mock out the hardware. You may be saying, John, isn't that kind of the whole point of a Nerves project is working with hardware? Why would we want to mock that out? And the answer is a little complicated, but basically developing against hardware is slow. If I want to, move a new element on my web page to the right a little bit, and I'm developing on the hardware, I have to change the code. I have to burn it to an SD card. I have to plug that into my Raspberry Pi. I have to wait for the Raspberry Pi to turn on. I might have to reset my printer. And then, oh, it turns out I moved it too far. I've got to move it back. So if you can mock that out and test that on your desktop, things will go much better. Additionally, testing is almost impossible. Like, let's say I wanted to write a test that says, move the extruder 10 centimeters to the left. If I'm running tests against the hardware, there's no way to really assert that the extruder moved in real life. I'd have to kind of like stand there and look at my printer every time we're in the test suite, and it's just not realistic. And so most of the time when we talk about mocking in Elixir, people often use a behavior. But in this case, the connections that we're mocking out, I thought they would have state. They'd have a bit of state to each of them. And so you'd be passing that connection to behavior function calls every single time you're calling them. And to me, a protocol seems a much better fit for sort of this mocking out of the connections. So why mock this connection exactly? And when I like to think about mocking things out in an application, I like to think about what's at the edge of my application. What's the part right at the edge of the system that's going to be talking to those external systems? So you can kind of think about, if you've ever written tests before and you're making remote calls to an API in production, you don't necessarily want to make those API calls in tests, because what if the server goes down? Then all your tests are going to fail. Or if they update something and you're not ready for it, your tests are going to fail. So it's all about getting that sort of reliability at the edge of your application. And again, in different environments, they kind of have different needs, right? So in production, we're going to want to talk to a real 3D printer. That's what our connection is going to do. But in test, we maybe want to replicate error scenarios or check that correct messages are sent. And development, it'd be ideal if we could mimic a real 3D printer as closely as possible. So we're going to talk about a little bit about the different connections that I built to work with this project. And the first up is the serial connection. So this is our production connection. This is the one that actually uses the circuits UART library to send messages to the printer over USB. And when I was designing the connection protocol, I took a look at the secrets UART API because I knew that at the end of the day, that was the one that was the most important. And that was the one we wanted to mimic closely. And so a lot of the serial connection implementations of the protocol are really, really boring because they're just calls to the underlying library. And so you can see here, this is the send implementation for the serial connection. And it's almost an exact direct pass-through to the UART library. We're just writing a message to the serial connection. And again, there's other functions like open and close for this protocol, and they're all very straightforward, just pretty much pass-through calls to the UART library. So one of the other connections that's a little more interesting, I think, is the in-memory connection. And so this is one of the connections I used for tests. And it keeps kind of a history of function calls. So if you call send, it's going to record that. If you call open, it's going to record that. And so taking a look at the implementation of send for the in-memory connection, we can see that instead of sending a message by the circuit's UART library, we're actually updating an agent at a PID, right? And all we're doing in this send function is we're saying, hey, somebody called send with this message, and we're adding it to the list of messages that we already have received. And that allows us to write tests like this, where I can say, hey, printer, I want you to heat up to 60 degrees Celsius, right? And kind of like you get, connections in your Phoenix controller tests, you can say, hey, what was the last message sent on, my in-memory connection? And it'll go into that agent and it'll pull out the last message and it says, oh, it was send and it matched this value. And so it makes writing those tests where, like, I don't want to look at my printer when I'm running the test. It makes those pretty straightforward because the edge of the application is kind of marked out. And so the last connection I want to talk about, and the one that I think is the most interesting, is the virtual connection. And so this is the connection I used for development. And so when I was talking before about like the needs of the different environments, in development, I mentioned it'd be pretty cool if we could like talk to a virtual printer without talking to a real printer, because a real printer is kind of a little bit cumbersome. And it turns out Octoprint already thought of this. So they have a virtual printer Python class, which is essentially just a bunch of Python code that mimics a 3D printer firmware. It's hundreds of line longs and super complex, but you can send it messages and it'll send back responses that are basically how a printer would respond. And so while that's written in Python, Elixir and Erlang has this feature called ports, which allows you to spawn an external process and sort of manage that process and send messages to it via standard in and out. And so I went one level deeper and found this library called ElixirPort, which is a wrapper around the Elixir Erlang port library. And it allows you to spawn Python processes directly in a much more friendlier way. You can say, hey, I have all my scripts in this folder. Can you load those into the Python runtime? And on the Python side, they've written a bunch of Python code that allows you to pass messages back to your Elixir code or your Erlang code as though they were, you were in Elixir itself. And so we'll take a look at that. So here's the send implementation for the virtual connection. Again, we've got a PID. And so you see, we've got this Python atom, and that's actually the ElixirPort library. And what this is saying is we're saying, hey, there's a Python process at that PID. And that Python process has a virtual script. And in that Python virtual script, there's a function called write. And I want you to pass these arguments to that function. This is very similar to like if you've ever seen the module function arguments calls that are sort of all sprinkled around Elixir and Erlang. And then on the Python side, it's going to get that message. It's going to send it to the virtual printer. It's going to process. It's going to get the response, and we want it to send it back to us. And ideally, it would be sent back to our printer server process, like we would do in Elixir, like this top line, process.send. You've got a PID. We've got a tag tuple with some data. It's great. And so fortunately for us, that ElixirPort library, they've written Python code that does exactly that. So we have this function called cast. It takes a PID. We're passing the Python version of a tuple, and you can build atoms in Python with the ElixirPort library, and we're just sending back some data. So these two lines are functionally equivalent, but it makes working on the Python side super interesting because you can just treat it like it was Elixir, and you're sending messages to processes. And so it made for a really nice development environment. So that's the connections. Now we're going to talk a little bit more about the printer server. And so the printer server, one of the main things that it does is it sort of powers the API, and it keeps track of the state of what is the printer actually doing. Are we connected to somebody? Are there messages in the message queue? Are we printing? What's the temperature? Things like that. It's also responsible for sort of parsing messages from the printer and figuring out what to do next. And so going in, I was sort of daunted by this printing. You saw I put it towards the bottom, and I was like, printing is going to be really difficult. I have that feeling. And one of the reasons I thought this was sort of every 3D printer firmware is just different. There's hundreds of G-code commands, and there's a wiki that sort of lists out what the commands are and what parameters they take, and it has tables like this listing, does the firmware support this command? Does it not support this command? Who knows if it supports this command? So I saw when I started digging into G-code, this kind of scared me. I was like, oh man, this is going to be really hard to send commands. While we're on the subject of G-code, G-code is the sort of command format that you use to send messages to a 3D printer. So this is an example of a G-code command. The bit on the left in gray is the line number. And essentially, when you send a command to a printer, it expects the next command to be one line number above it. So for example, if we sent this N1 command, the next command it would expect to be N2, N3, and so on. And if you kind of send commands out of order, it's going to complain and ask you to resend a specific line number. The green bit in the middle is the actual command telling the printer what to do. So in this case, a G0 command is a move command, and it's saying, hey, printer, move the extruder on the x-axis 12 units. And then that orange bit at the end is a checksum. So when you build this command, we take the bits from the line number and the actual command bit itself, and we run some bitwise operations on them, and we come up with this checksum. And we send that with the command. And the printer firmware is going to do the same thing. And if the checksums don't match, it knows that there was some data corruption on the line. And so it's going to ask you to maybe resend a command over again. So it turns out once I got down to actually sending the commands, parsing the responses was difficult, even if sending the commands wasn't. And so let's take a look at why that is. So one of the most common responses that can come back from the printer is just the string OK. And OK means I received the last command you sent. Sometimes OK comes with extra data, which is kind of weird for the parser. You can't just parse for OK. You have to check if there's also extra data and maybe parse that too. And then helpfully, it doesn't actually include the line number that it's acknowledging. It just says, hey, I got that last command. So you have to keep track of not only the commands you sent, but what order you sent them in order to kind of acknowledge them off the stack. Another message that you can get back from the printer is a resending of a specific line. And so this would be like, hey, please resend line 100. But unfortunately, while OK is just like a singular command, resend a command is actually 3 different lines. So it's like an error line, a line with the number to resend, and then the OK command again. So now not only do we have to keep track of these OKs, you have to keep track of when, you have to keep track of the last couple of responses you've received from the printer, just in case they actually form one like big meta response. And so here's a couple examples of like some response lines you could receive from a printer. The top two lines are temperature status lines. They contain information about like what the temperature the printer's at. And that first line is from the virtual printer. And so that's kind of the one that I had built a parser against and tested against. And that second line is from my actual printer. And for some reason, it has like some white space at the beginning, which is not part of the spec and not listed anywhere. And it completely blew up my parser when I plugged in the printer. I was like, why isn't the temperature data coming through? So it's just an example of like some of these weird formatting errors that you can run to. And then below that, we've got two OK lines. And one of those has just some temperature data that's kind of similar to the stuff up top. So when it became apparent that like parsing was kind of the real problem, I tried to come up with some good solutions, and I came up with a few. And the first two that sort of popped in my head were regular expressions and sort of pattern matching. And I played around with these a bit. And basically, I found that they were kind of either too inflexible or a little too hard to read or debug, and they just kind of weren't what I was looking for. So I dug a little bit deeper, and I found this library called NimbleParsec. And so NimbleParsec is a library that allows you to build text parsers that are easy to combine with other text parsers. So it's easier. We're going to take a look at an example. I think it'll make it a little more clear. So this is a parser for extruder temperature. And we're saying, hey, extruder temperature, it starts with the string T:, and we don't actually care about that part. We care about the floating point value that comes after that. And similarly, here's a bed temperature parser. It starts with B:, and we don't actually care about that part, so you can ignore it. But we do care about the float that comes after that, so we're going to return that. And you can build small parsers like this and combine them into a bigger parser that matches sort of that OK temperature string that we saw earlier, where you can say, hey, the string starts with OK and a space, and we don't care about that. But we do care about the extruder temperature, and we don't care about a bit in the middle, and we do care about the bed temperature at the end. So I found this approach to be the right combination of easy to read and understand and debug. And it's also fairly performant because it actually compiles down to pattern matching when you build the library. So that was pretty cool. And it turns out I was kind of wrong about the printing thing. Printing was actually pretty simple. And that comes down to the way that the printer application kind of sends messages. So the way messages are sent is somebody will call an API or make an API call and say, hey, printer, I want you to move, or I want you to heat up. And if we're not in the middle of sending a command, that command gets sent right away. Otherwise, it gets put into a message queue. And so the printer, sends a command, it waits for a response, it processes that response. And then if there's more messages in the queue, it just repeats it all over again until the queue is empty. And then we're just kind of waiting for someone to send an API call. And this actually kind of unintentionally mimics printing, except instead of a queue, when you're printing a file, it's just a file full of G-code commands. So instead of reading from the queue, you can say, send a message from the file, wait for the response, process that response, and if everything went well, you just read the next message from the file. And so that was kind of cool. It's like, oh, this just kind of works. That's great. And so now we're on to the last application, and that's the UI application. And this is our Phoenix Liveview, where we've got our UI, and it depends on our printer application and sort of uses that like an API. And I expected this one to be a little bit challenging too. And it was honestly like the Nerves one, where it was really, really straightforward, and most of the work was kind of in the actual printer application. So here we have a mount for that component that we saw on the previous screen. And if we're connected, we want to subscribe to updates from the printer. It's going to send us a status of what's going on, if it's heating up or moving or something. And then additionally, we're going to grab some printer. We're going to grab the current status, and we're going to assign it to a printer, the printer assign, and we're going to grab the currently available connections, just in case we want to connect to one of those. And then messages come in just like you would expect, normal Phoenix PubSub messages to come in, because that's what the printer application is using under the hood. There's just a status struct that's broadcast to anybody who's listening. You get it on a handle info, and we just update the assigns, and that causes the UI to re-render like your normal live view. So again, that status component, like it's just pulling that status out and just displaying it on screen. It was very, very straightforward, just reading values from the thing. A little bit trickier was sort of the move buttons, but again, that wound up being also almost pretty straightforward, because you define a component like this where we're passing, the amount we want to move and what axis we want to move on, and it's sort of rendering it. And when somebody clicks on the button, it fires a move event. And getting down to implementing that move event, I was just calling these APIs. I was like, this is really simple. Like the printer API exists. We just kind of pass the parameters on through to the printer API. I was like, is this going to work? Is this really going to work? And the answer is, yeah, it kind of just worked. I plugged it into my printer and it did its thing. So revisiting those goals I set for myself at the beginning of the project. The ones in green, I would say success, completely done, great. Unfortunately, I discovered a bug in the printing code the other day where the firmware thinks that we are one command line behind where the application thinks we are. And it's asking the firmware, or it's asking the printer application to resend lines over and over and over again. And it causes like this stuttering and back and forth. And it took me a while to figure out what's going on. But I'm confident with time that it's a pretty simple fix. I think it's just an off by one or a race condition somewhere. And unfortunately, I just didn't get up to file uploading in time. So what went well writing this project? Honestly, it felt good. It felt like building a normal Elixir application. The Poncho structure just sort of let me not worry too much about Nerves and not worry too much about Liveview or Phoenix, and just like do the thing I was normally doing. I was just writing Elixir code. Additionally, I had done some Nerves projects before, and it feels like Nerves has really grown up. Before, when you did like mixnerves.new, a lot of things were like kind of piecemeal. You'd have to say, oh, well, I want to connect to a Wi-Fi network, so I have to pull in this library. Or I want to do firmware upload, so I have to pull in this library and configure this thing. But all of those libraries, they're still there, but now they're included with the mixnerves.new generator, and it's a much more seamless and pleasant experience. So I was happily surprised about that. And then I feel different connections were the right way to go. When I started this project, like right after I started this project, my printer broke. So I spent 90% of the time developing on this project against the virtual printer plugin. And I was able to write code without having a real 3D printer while I fixed my 3D printer, and then was able to plug it in and start running commands. And it pretty much just worked outside of a couple parsing errors. And that was an excellent feeling. And I think it's a testament to sort of that mocking strategy and Nerves and being able to, you don't always have to have access to the hardware that you're developing against if you have a good sort of foundation. What didn't go so well? I was honestly surprised by the lack of like a singular 3D printing spec. It's wild to me that every firmware just kind of does whatever it's going to do and sends its own responses. And like I said, I was developing against a virtual printer plugin, and then I plugged it into my real printer, and all of a sudden there's just random spaces here and there. And so there was a bit of guess and check. And as I'm kind of digging around into this on the internet, I find a lot of other developers who are very not pleased with the same sort of thing. Also, I feel like response parsing could really be improved. Currently, the connection is sort of just passing back the raw data that it gets from the printer. And I feel like it might be better if the connection actually parsed the data itself and emitted events like, okay, or please resend this line. And that would simplify, the printer server area and maybe make bugs like this, printing off by one, not so much of a thing. And then also it was just a bit of a humbling experience. You're kind of never too old for off by one errors. And so that's my talk. If you want to check out the code, it's up on GitHub at JWSonicCliffswallow. If you're into Twitter, you can follow me on Twitter. And then I'll answer questions while I play this video of my printer just kind of moving around, assuming that it works. Do we have any questions? Oh, there we go. You're muted, Richie.
Hey. Congratulations on the talk. I'm looking at the chat. It looks like we don't have questions yet. Hopefully we can have some of them soon. And but you got a lot of
circles.
Yeah, but you got really nice comments. People enjoying the talk. Nice work.
I'm glad to hear that. Thank you.
Very nice talk and bold statements you made during talk. So. Good. So let's see if we get a question, and if not, I'll thank you in advance for the talk.
I enjoyed doing it.
Will you be printing the Elixir droplet once your final issues are resolved?
Yeah, so that was what I was that was the first thing I thought of, to be quite honest. I wanted to print an ElixirConf thing and have it kind of in the background. Unfortunately, we didn't get there. And when I looked into it, there's actually I couldn't find a good 3D model of like the Elixir logo or a droplet. So if somebody has one of those or finds one of those or makes one of those, feel free to shoot it to me on Twitter and I'll print it once I can.
There's another, how does this project compare to the other ones you've done in Nerves?
In terms of the like, one of the other projects I did was I had a cat feeder that had some motors and it turned and it broke. And I pulled out the control board and replaced it with a Raspberry Pi and hooked it up to the motors. And so that one was very similar in that it's sort of the Poncho architecture with a web UI controlling some hardware. But the actual content was kind of different, right? It's not as complex as a 3D printer. You press the button or at a certain time it moved the motors and stuff. So similar, like that Poncho application is pretty, I find it pretty flexible and pretty pleasant to work with actually over like an umbrella application. But yeah, in terms of the content, they're pretty different.
Do you have Phoenix in the picture to have Liveview?
I'm not sure I understand that question. I think you're saying, do I have Phoenix so I can use Liveview? And if you're asking,
yeah, I think it's the plan.
Yeah, the dead views or whatever, as I guess they're called. Nothing really in the dead. It was just all kind of Liveview. There's a singular sort of live route and no real plans for kind of dead view stuff. Because this is, I think, one of the more ideal environments for Liveview because it's running on a Raspberry Pi in my house on my own network. And so I'm always going to be connected, right? Like you're always going to have a connection to the server. It's a very fast connection. So.
There's a new one. Do you plan to integrate it with a webcam, for time lapse?
So that would be like, I think, a stretch goal. That's something Octoprint does. And I think they have issues with the Raspberry Pi webcam and throughput. And so it'd be interesting to tackle that in Elixir. But when you get into like dealing with the Raspberry Pi webcam, it's a little weird. It's like a bunch of series of images. And so I've thought about it, but I don't have a concrete plan on how to move forward there yet.
Cool. I think that's all the questions we have right now.
All right. Thank you so much for hosting.
Thank you so much, John.
Yeah. Take care.